processing, human-computer interaction, machine learning algorithms, and cloud computing. He has made a prolific contributions to academia with over 180 publications comprising 2 books, 8 book chapters, 45 journal articles, and 130 conference papers. He has also filed 5 patents, out of which 3 have been granted. Over his 25 years of teaching and 13 years at IIT, Dr. Koolgudi has mentioned 60 plus MTech projects and guided 10 awarded PhD scholars, with 6 more currently under his supervision. He has successfully led 6 major research projects sponsored by the Department of Science and Technology, Government of India, securing funding worth 2 crores. Dr. Koolgudi is an active member of several professional bodies, including IEEE, ISDE, ACM, IE, ISC, and CSI. He is a sought-after speaker, has participated in more than 100 national and international workshops and conferences. He has also conducted numerous workshops across India, particularly on basics of speech and image processing with hands-on training. A testament to his impactful research, Dr. Koolgudi has recognized among the world's top 2% scientists in his field of Stanford University of 4 consecutive years since 2022. Under the guidance of Dr. Koolgudi, the work is being carried out by Garima Pandey and PTL, PhD research scholars, and Serena Gogoi, an MTech by research scholar. So we welcome you all for the FTP. Dr. Koolgudi has more than 5,000 citations for this scholarly work. Welcome you, sir. Once again, thank you, sir.
Thank you, madam, for a nice introduction, exhaustive introduction. So, good morning to all of you. Today we will be seeing something related to speech processing. So, whether anybody has got any experience on processing speech? Madam has got experience. So I have got the fear in my mind what I will tell you. Fine. Speech processing was a topic which we can relate very ancient days like Ramayana, Mahabharata. There, if speech processing was properly done, probably we would not have done speech processing at this level now. So we remember certain incidents at that time. Once that golden deer came when Rama and Sita were there together, and Rama goes for hunting it, and Maricha was a person behind that. While that the golden deer died, he shouts in the voice of Rama, like Sita, Lakshmana. So if that voice was properly recognized by Sita at that time, probably this entire Ramayana would not have happened. Similarly, in Mahabharata, once Ashwatthama's case comes, Dronacharya's son. So Krishna makes Dharmaraja to make a statement to Warfield. Ashwatthama Atha Kunjaraha. Kunjaraha was very slowly told. Kunjara means elephant. The name, elephant by name Ashwatthama died. He said like that. Actually, Dronacharya thought is his son died. Then the whole story, that whole battle changed. So just this is kind of introduction where our speech processing people thought of, and there were some things we did not worry about those things. Now, today's developments, today's achievements in speech processing is the aim of today's topic. So before going to the topic, so just something about my institution where I am working. This is NITK's local. This is you cannot, this will not go here. This is this side, left side. What you are seeing is the main building, NITK, which normally you see on website, and the other side, right side, what you are seeing is today's computer science department. And in 1960s, NITK was established as a KREC, Karnataka Regional Engineering College. And later in 2003, became NITK, one of the institutions of national importance. Then now we are 17th by rank, NIR rank, and all our BTech courses are accredited for 6 years for second consecutive slot. So Department of Computer Science offers one UC program, degree BTech in Computer Science and Engineering, and we have two PC programs and PhD program. Recently, we have started part-time PhD also. If any one of you are interested, you can explore that. So 9 faculty members are there in the department. We work all these areas like networks, medical imaging, speech processing, underwater communication. Our labs are open for 24 by 7 to all our students. This is just introduction about our.
A part-time PhD as not under QIP, like external candidates.
It is totally like a regular PhD. Earlier there was only regular PhD scheme. People have to come there, write written test, clear interview, and they get stipend from the central government, and they have to do PhD. The way these people are doing it. Now part-time also, you are working somewhere, central government organization or some college. You can come there, complete coursework, go back to your institution, continue your PhD. Normally, we don't encourage part-time because PhD is a dedicated, continuous process. But still, that option is there. So this is what is the backside? This blue region that you are seeing. That's a Arabian Sea, and the beach is between this forest and that sea. So this is a photo taken from the window of the corridor in front of my cabin. At least to see this, you can come to NLTK. I invite all of you for that. So today's discussions are basically on what is the motivation for us to work on speech processing. Then what actually speech processing is, what people or researchers do in speech processing. And what are the issues those researchers are trying to solve in speech processing? Probably you may take some takeaways from that. You can give them to as projects to your students, or you yourself can work on that. And what are the today's solutions to these issues in the area of speech processing? Earlier, at least some of us know that in 90s, the way we used to interact with computers is through some commands. We used to type, if I want to copy one file to the other file, I have to type the whole source directory and then destination directory with some command without missing any space or comma, anything in between. That kind of interaction with the computer was known as character user interface, command user interface, where computer literacy means you need to remember all these commands so that you can very perfectly work with the system. So user base was very less because people were not comfortable with this kind of interface. So slowly, when Windows operating system came into the picture, GUI, graphical user interface, which we call, where there is no much remembering kind of a thing. You have to operate certain things like left click, right click, drag and drop, these kind of things. And when using this majority of the activities, you could do. Last one, SUI is the top speech-based user interface. That's ultimate one. Speech-based user interface means you should be able to instruct your computer through your voice. I will be talking to my computer. Computer understands it. It does something for me, and it talks back to me. The way we are talking with our parents, with our friends, with our spouses, with our children, something like that. But now, once I say all these things, the mode of speaking, the emotions, the words that we have used, all are different. That we have to be very careful. While I speak, my parents, my seniors, my children, my spouse, my friends, the communication is not same. So all those things computers are expected to learn if we go for speech user interface. But it is not completely come yet. So in between GUI and SUI, there is one more interface which is very popular because of that computers have become very widely used now. What is that? Which I have not written here. All your smartphones are not nothing less than a computer. How do you interact with your smartphone? Swiping, touchscreen. Touchscreen is one more very important medium of interface. So that has become, because of that, now anybody who has not got conventional literacy can use systems, computers, phones. So speech comes, the communication will be more effective. And question comes, why speech is so popular? Because it's a common, um, by default, we have communication between human beings. Speech is the most convenient, commonly used mode of communication, and visual contacts are not required. So, our mother's instead in the morning being in the other room, what we have to do, we are in the other room, isn't it? That's not required. Then, special equipment is not required other than some microphone and speakers, and can be done along with doing other things. While driving car, we hear songs, isn't it? We speak to someone, our friends. So speech is more effective in case of common people. Special literacy is not required because we learn it by our work. Application. There's so many very important applications. So that motivates all of us to work in this area. First one is human computer interface, the one which I said earlier. If it is more user friendly, then user base of computers will be wider, so that our work will be more efficient. So speech is a biometric signature. That's one more important thing. So how do you put your attendance every day once you come to your institution? Now, thumb. That's one biometric trait of a human being. It will not change. It is unique for me. So using which I try to recognize myself. Earlier there used to be signatures. I used to put signature on paper. Some seniors might be knowing that every day once we come to college, there used to be one register and we used to sign in that. That's attendance, kind of attendance. Some senior people to us, they used to sign and go home. That's different thing. Let us not worry about those kind of people. But that kind of signature is vulnerable to forging. You might have seen many such things are happening. Some signatures are forged, documents are prepared. So instead of making a signature and leaving a vulnerability of somebody quoting it, can we use some of our biological traits as our signature? That was a thought. So many things have come. Very important thing which normally every day we are using everywhere is thumb. So there's a scanner, we scan your thumb. The same thing is there in case of our Aadhaar cards also. Our Aadhaar identity is mainly because of those impressions of the fingers. But that is again, there was a huge discussion about this once COVID has attacked. During COVID used to spread just by touch. Same person's using the scanner, everyone comes and puts his thumb. Then if one person has got COVID, everyone in the industry, organization, next day will be COVID patients, isn't it? So we stopped using that. It was not encouraged at that time. Then people started thinking of other similar signatures. Then face recognition came into picture, iris recognition. Those were there earlier, but commercially those were not being used. Similarly, at the same time, people also thought why voice cannot be used as a signature. Individual voices are different, isn't it? If you have got an experience of talking to your friend on a phone whom you have met 10 years back, just if he says hello, you can recognize him. Number is not in your contact, you will not recognize the number. Once he says hello, immediately you will recognize him or her. Isn't it? It means each voice, everybody's voice has got some unique features. Using those features, we can recognize a person. So can we use this voice or a speech as a biometric signature of a person? So now how do we get your banking transactions done, financial transactions? Through phone, through some OTPs, and because of those OTPs, so many digital frauds are happening. They somehow cheat you, they take your OTPs and they transfer all your money. So instead of that, can you say just your name on a phone? Whenever a call comes, you can put your name. That voice is processed at the other side server. It recognizes that it's your voice. Then the transactions can be done.
With precision will work because some mimicry artist if they speak.
Yes, sir. That I will
It will not be
like to come to that. In speech processing, there are different levels of recognizing a speech. Normally, human beings recognize a speech from the exterior characteristics of the speech signal, like how much long, means how slow I speak, how fast I speak, then what is the intonation I use. I will come to all these points later in my talk. Those are called as prosodic features. So human beings, whenever they mimic somebody else's speeches, Like Modi's speech, many people will mimic, and the great artists like Amitabh Bachchan's speech.
Sir, AI also is doing that because nowadays we see in Instagrams and all, Nirmala Sitharaman is telling about some project to invest 21,000 per month and getting 1.5 million views.
Those are to deceive human ears, because human ears also process prosodic features. So we hear the speech like that. So only when those features are modified, my speech will be heard as somebody else's speech, Modi's speech or Nirmala Sitharaman's speech. But once computers we use for speech processing, we can go to the depth where some lot of maths is involved, and that way of understanding human beings normally cannot do. So when we go to that level, probably mimicked artist's speech also can be recognized, whether it's a fake speech or original speech. So those features we will see little later. But the question is very relevant question, and keep asking such questions, because I speak normally from my understanding point of view, but the basic doubts what you have, I might fail in anticipating them. So if you keep asking, then there will be good conversation and useful interaction. So biometric signature can be used, especially we have heard many CD ghotalas, DVD ghotalas, isn't it, where somebody's voice we hear and say that this minister is saying that, that minister is saying this. All those things, if we have scientific method, proper method to tell that this voice belongs to this person, then problem is closed, isn't it? There is nothing much discussion on that. But majority of such issues are not closed, because our court of law is not accepting speech processing tools as an evidence in the court. If scientific methodology using which we can prove that this voice is of this person, if that is accepted in the court, majority of these cases can very easily be solved. So can we do that? That is a speech, using speech as a biometric signature. Then dictation engine, almost this has become a reality now. In Google, you have, if you go on speaking, then you get related text on your monitor. Earlier, whenever titles, subtitles used to come in the movies that we see of the other language, they were to be prepared in advance, and then they used to play them. Now that is not the case. You have large language models, all of them will be automatically done. But have you observed what's the lacking in that? Whenever you see a text, whatever you speak, you see a text at the bottom. Did you observe what's the lacking in the text? Anyone?
Maybe words.
Punctuations are not
Spelling mistakes. Sometimes spelling mistakes are there, but once large language models have come, language model is attached with this translation. Means if some word is not there in the dictionary, that will not be put there. Probably the nearest word is put there.
Slang.
That might not always be meaningful, but 99% of the cases it will be meaningful. But major important thing which is observed is there are no punctuation marks, or punctuation marks are not properly put.
Yes.
If punctuation marks are not properly put, what is going to happen that we know?
Intentions may differ.
Intentions are made different. Say for example, I have a statement, I have not written that altogether, suddenly it has come. So hang him, not leave him.
Not.
Hang him, comma, not leave him. Hang him not, comma, leave him. So totally the judgment, interpretation of judgment is changed. So that much important the punctuation marks are. But today's dictation engines are not totally equipped with this punctuation marks. That's a very good research area.
And
Some of us can take
probably
into
there is no support for regional languages yet to come.
support of that is yet to come. It will come. It will come in the ways in the days to come.
Movies, sir, all the movies now are available in all the languages.
Subtitles
in Kannada.
Titles, but
Voice
No,
that's different
so
story.
we are talking about real-time translation.
Translation.
Real time means whenever I am talking, suddenly it should come. Not
what I am
pre-processed.
asking is it real time like
No, sir. No.
pre?
They are recorded. They are
All of them are recorded. So all of
Recorded.
them are pre-processed and pre-recorded, and then they play it accordingly. Earlier, whatever we were seeing, but now you have Google applications and many applications. Those are real time. Whenever they become real time, there are some supporting issues also, like punctuation. Earlier in TD and all, what we used to say, they were not real time. They were before in advance.
So I was talking about
having a common movie, different languages and entities.
Real.
So
No, that is dubbing.
that is dubbing.
That
That's
is
what I-
dubbing. That is with a different effort it is done. It is not automatically
online
done.
translation.
If what we are able to do, one of the
Then-
applications is also like that. Say for example, somebody's Kishore Kumar's voice is very melodious voice. I want now one song to be recorded using Kishore Kumar's voice
In Kannada language.
in Kannada language. That is not possible now. But if your AI becomes very powerful, that's also possible. That's a possibility now. Everything we are doing now. Majority of things we are doing now. So AI will reach that stage in another 4 years. It's a prediction, not prediction by me. It's prediction by the people who are experts like Elon Musk. What they say is by 2029, one computer will have a knowledge, intelligence, which is sum of every person's knowledge put together on this earth. Means one computer system will be so powerful that it includes everybody's knowledge. We have different expertise. Lawyers are there, doctors are there, administrators are there, Bill Clinton is there, Donald Trump is there. Everybody's knowledge will be there in one system. One system can act as all these expert people. So see, the future, maybe it is for betterment, it is for not betterment. This is not the forum for discussing that, but that will happen. So dictation engine, then IVRS you might have heard, interactive voice response system. Where did you hear?
Bank. We call the bank.
Helplines, customer care.
Gas booking, customer cares. So, but there the name is IVRS, but normally it is not IVRS.
Okay.
Press 1 to do this, press 2 to do this. So text-based interaction again. The processing speech is not 100% achieved goal.
Oh, voice based also, they are asking to say some words.
Yes. That's an improvement. That is an improvement over those systems. It's happening. But completely it has not happened. There are so many research issues in that, especially for the people who are not able to type something on the screen, for those kind of people.
So complete idea steps, right? It asks say yes or no. Instead of pressing the
That way it's happening, sir. Even while you enter into your SBI online SBI portal, earlier it was only text-based input. Now it will tell you to say some numbers. If it is matching, then it's not only number matching, it is your voice also.
So all those service center asking like that, if it is service, say workshop.
Yes. So those things are coming. But slowly, step by step, they are coming. So there's a huge scope in the research in case of IVRs. Then mobile applications, many mobile applications. Say for example, now we have seen voice dialing. If I say home, then it will search through entire contacts, search contact with the name home, it will dial that. While driving without touching my mobile, I can do that.
Play the music.
Yes, so it's called as voice dialing. There are many such applications. Say for example, I'm talking to my boss. I'm in a railway station. There is a railway sound, a lot of sound. So then I'm not comfortable talking to him or her. Then probably if we have some noise cancellation applications which cancel all the supporting surrounding noises and only my voice is transmitted. That's a very good application. It has not come yet. Not yet come. So those kind of, nowadays everyone has got mobiles. So mobile related so many activities we do. But if there are certain apps which will help certain things, that would be better. So apart from this, there are many things like using speech. We can also recognize the age of a person, not very accurately to the date of birth, but at least for 5 months, 1 year tolerance limit, we can recognize age of a person. You know, very small children like 3 years, 4 years, how their speech used to be. Once they become 18, 20 years, their voice changes. When they become 40, 45, again voice changes. 50, 60, 70, 80, voice changes. So we will be able to recognize. So if we do that, there will be tremendous revolution in the society. Now, majority of the situations you might be reading in the newspapers, that bogus voting. I take my brother's voter ID card, my brother somewhere in Dubai, and I'll go in name of him, I will vote. I'm 15, he is 18, 19. So there is no proof that who is who, whether I can do voting or not. Instead of that, you ask that person to speak on a microphone, just tell his name. Then if you have one system which roughly tells his age, he is not more than 15, not more than 16, then you have a chance of next inquiry. And if you go to this Iraq shop and all, normally the people below 21 years should not get whiskey, brandy, all these kind of things. Their testing can be done. Driving license. Below 18, you cannot get driving license. So preliminary test to decide whether a person has attained this much age. All those things can be done. Many such applications are there. These are all the motivations for us to work in the area of speech processing. So now we will go one step down, little technical details of what speech is. Because for human beings, it is very natural. Since childhood, we hear, we learn, we acquire that knowledge, we use it, comes by birth. But for machines, it is just some waveform. Signal is single dimensional waveform. That waveform we have to process what it is. So we will go into little details in the next slide. But we need to know that it is a non-stationary waveform. Stationary waveform means it is same. We can predict it. If the waveform is like this, in the next 1 second, how that waveform is. If prediction, perfect prediction is possible, then we call it a stationary, not changing, something like that. But that kind, speech is not that kind. It's non-stationary. It is changing continuously with respect to time. And we assume that for the short interval of time, it is stationary, so that we can apply all our electronics knowledge which we have learned. All those principles normally work on stationary signals, stationary waveform. So we can apply that on that. We will see that later. Don't worry about that. So speech waveform looks like this. Along x-axis we have time. Along y-axis we have amplitude. Amplitude means it's the signal strength. So what's the value of the signal along y-axis that we show? So one specific speech signal I have shown here. It is speech lab. Speech lab is spoken, and the waveform look like this. So here you can see there are some regions. So these regions where some periodicity, we call it again quasi-periodicity. Quasi-periodicity we see here. We see nothing is here, some region. And this quasi-periodicity is with very high amplitude. Again, nothing is here. And we have some noise kind of signal which is not quasi-periodic, but some zigzag signal. So these kind of different things we are seeing here. Whenever there is a vowel, pronunciation of a vowel, signal looks quasi-periodic. We will see why it is like that later. Don't worry about that. Whenever we pronounce certain consonants, then there is no signal. It's called a silence region. Silence region. And whenever we pronounce certain fricatives means sh, s, these kind of things. These kind of things. A noise signal looks like a noise. So general understanding. Always you cannot very clearly bifurcate like this. But some general understanding is like this. And we have certain semi-vowels. Here, these are called semi-vowels. All are vowels. Semi-vowels are there. Signal used to be like this. L is a semi-vowel. Lab, L. A is a vowel. So once we expand the region between L and this is vowel, this is semi-vowel. Periodicity is there, but you see the difference between this signal and this signal. I have enlarged this portion. See the difference between this and this. Once I say quasi-periodic, we see cycle kind of structures, but it's not a very specific cycle like sinusoidal signal. You have sine signal, cosine signal, those are called sinusoidal signals. There, the signal is generated using some mathematical function like cos theta, sin theta, sin 0, 1, 2, 3. In place of theta, you enter all values. Very nice sinusoidal signal you get, but it is not like that. That is exactly periodic signal. This is quasi-periodic signal, not exactly like the cycle, but there are some cycling from here to here. I can say that. Should I not touch this? Here to here there is one cycle, second cycle, third cycle, fourth cycle. You can observe that. But here also cycles. This is semi-vowel. Cycle structure is different. So how human beings produce voice? We are producing voice since 30 years, 40 years, isn't it? How do we produce voice? Any idea? Any way that you have understood, you can tell. How do we produce voice? Normally, before producing a voice, we inhale air.